Now, in this video, we're going to be looking at calculating the distance between a point and a line in 3 space, so in R3, 3 dimensions. So we're going to need a point in space, which should be provided to us, a point on the line, and the direction vector for the line. So let's start with identifying our direction vector. Our direction vector U is going to be, and if it's in this form, in the parametric form or in vector valued function form, you're essentially just going to pull the coefficients off of the t's. So this will be 3, -2, and 1. 3, -2, and 1. Now, the alternative form, like symmetric equation form, this would be x minus 1 over 3 is equal to y minus 6 over -2 and z minus 8 over 1. This would be the symmetric form. And in this case, you would pull the coefficients essentially out of the denominator. You do have to be a little careful with the negative signs because sometimes they're distributed through the numerator to switch the order. So 6 minus y over 2 would still pull out a -2. But symmetric form, you would pick basically the denominators. In parametric form or vector valued function form, it's just the coefficients of t in your system. All right, so that's our u vector. And what we're going to do is we're going to pick a point on the line. So find a point on the line. So that's the first step. Now, this is very easy. Pick a value for t, you get a point on the line. So in this case, I'm just going to let t be equal to 0 to make my life easy. And so my point on the line is going to be -2, 6, and 8. And so then I need to find PQ. Now PQ, remember, is going to be Q minus P in that form. So -1 minus 4 is going to give me -5. 6 minus a -2 is going to give me 8. And then 8 minus 1 is going to give me 7. So that's my PQ vector. Now the formula for the distance here, it says that I'm either going to cross PQ with the distance vector, the direction vector, and then divide by the magnitude of that vector, or I can create the unit vector and then do the crossing, just to make so that I'm not using quite so many fractions and square roots and things. I'm going to do the cross product first, and then I'll come back and worry about the magnitude of my direction vector. So PQ crossed with U So we've got I, J, K up here. And then PQ, -5, 8, 7. And then U, 3, -2, 1. And I'm going to get, for my I component, 8 times 1 is 8. And then minus -2 times 7 is -14, so plus 14. And then my J component is going to be minus -5 minus 21. So 3 times 7 and negative 5 times 1. And then my k component will be 10 minus 24. So that's going to give me 8 and 14 is 22. Negative 5 and negative 21 is going to give me negative 26, but there's another negative out front, so that's positive 26. And then 10 minus 24 is going to be negative 14. And this is a vector, but I need a distance. So what I need to do is I need to take the magnitude of this distance so the magnitude of PQ cross U is going to be 22 squared, I believe is 484. 484. 26 squared is 676. And 14 squared is 196. And if I add those up, I get 1356, which is going to be equal to 2 times the square root 339. And I don't know that that can be simplified any further. Trying to think of perfect squares that might divide into that, and nothing is really coming to mind. So I think that's about as much as we can simplify. I divided out of 4 and then pulled the 2 outside the radical. And then I'm going to need to find the magnitude of the direction vector. And again, you should expect that in most problems, you will not get nice numbers out of these. You'll get crazy radicals, and that's just how it is. So this is 9 plus 4 plus 1, which is going to be the square root of 14. And so the distance is going to be 2 and the square root of 339 divided by the square root of 14. Now, it's possible that you could check to see if 339 divided by any factors of 14, but 339 does not divide by 7, so this you really can't simplify this very much past this.